So hi guys, and today we all are here for the knowledge sharing of the topic Apache Solr, and I would be taking you on a 1 hour long journey of, and I'm going to assist you with exploring Apache Solr today. And I have been in IT for about 9 years, so working on Solr for last 6.5, more than 6.5 years. So I started off working on Apache Solr 2.2, and since then I have seen it growing and growing. I mean, it's getting better and better with each releases. They have made this thing so fabulous. So we would be discussing what makes it so fabulous, and we would discuss that what makes it so powerful and so sought after. So we're going to be starting off with the Apache Solr, and we would be exploring the new age of search through this tool. And this is a very, very powerful tool, I tell you guys. So, end of this session, basically, you would be understanding that what is the need of a search engine for an enterprise grade application, the objective and challenges of the search engine. How is indexing and searching handled in Lucene? I mean, as of now, if you guys are wondering why are we discussing Lucene as well, I mean, the session was actually designated to be talking about Apache Solr. So we would be discussing why we are actually talking about Lucene as well, because Lucene is actually the magic backend in the hood of Apache Solr. Then we would be exploring the Solr and its architecture. We would be talking about the near real-time search with the Solr and Solr Cloud. Then we would also be talking about leveraging the capabilities of Solr along with Hadoop. And we would be discussing a little brief about Yarn as well. I mean, how can we configure and leverage the capabilities which are delivered by Yarn through Solr? And again, the foremost and the main concern why we are here is the job opportunities for the developers who work on Solr. So if we are good enough, we can begin this journey. So let me just first of all begin with a very basic idea of what Solr is giving to a web application. So any idea, guys, why would we really need a search engine? I mean, we all know, and I believe we all do understand and acknowledge that Apache Solr is basically leveraging the search capabilities in your maybe new application or existing application. So why do you think search is so important? Why do you think we would need the search capability on any web application? Any thoughts? Any inputs? Okay, Kunal shares that in order to accommodate for search that is not exact, accounts for spelling mistakes, phonetics, etc. Okay, that's quite a deep dive, Kunal. So great. I mean, if you do understand all of that. However, from a layman point of view, what do you think? Okay, there is too much data to be searched for. So you would need search engine to organize your search. Okay, right. So okay, so two most and foremost, I would say, reasons why anyone would like to have a search engine or search capability on their web application is speed and relevancy. I think everything would be summarized with these 2 points. First of all, we would like to attain speed. The results should come as soon as you type, or at least in a blink of few nanoseconds actually. And then the search string or the search text which you're looking for, the results should be pretty relevant to your content you're looking for. So we have few more inputs here, because executing like okay, maybe like as in SQL, yeah, that's pretty slow. True. Pavan says complex search queries can be slow to run, so we would need search engine. Absolutely. So actually, I mean, most of us do understand why we would need a tool like Solr or Elasticsearch in our application. So this is basically to boost search, and why would we need search is to attain the speed and relevancy on any application. So if you look here, we have put up a snapshot. Maybe we do not have the web application, as a site of this particular e-commerce website, but we've just taken a little example of what search engines or what search gives to your application. So if you look here, there's a very fancy snapshot which we have taken from flipkart.com. I'm sure every one of you must have visited this website once in your lifetime. So looking here, we were looking for quad core mobile, and this is the search string, search text which we have entered in our text field, which provides us the search capabilities on the application. So if you look here, we have few suggestions on this particular text, that are you looking for quad core mobile phones with KitKat OS, or the Sony mobile phones with quad core processor, or maybe the quad core mobile phones with 4.5 inches of screen. So it's like a auto suggestion thing which has already been activated on your website, which is basically enabling the user, it is basically assisting the user to make the search more precise so that they can get more relevant results. Along with that, they have a very nice feature accommodated therein, which is also talking about the popular products with maybe similar search string. Along with that, if you notice the left hand side of the snapshot, you have a very nice grouping done as well. Maybe I'm not very sure what kind of configuration of mobile phones I'm looking for, but I'm sure that I need a phone between say 10,000 to 18,000 of range. I would just quickly go ahead and select this particular group on my left hand side, and I get all the products which fall under that particular group of 10,000 to 18,000. Or maybe I'm very particular about a brand to own, and I say that I'm actually looking forward to own HTC as of now. So I just quickly go ahead and say that I'm looking for a phone in the range of say 10,000 or 18,000 to 25,000 of range, considering HTC mobile phones are little pricey. So I say that I select the brand of my choice, and I give a price range of the phones I might be looking for, and I get neat results. So all the results which I get are also sorted in the manner I would like to see them. Maybe I would like to see the results sorted on the basis of the prices they have. Along with that, I do also see that few of the features have already been listed here. A very small and kind of comprehensive information about the user rating, the price range, few quick features like what kind of processor it has, and what kind of camera it has. These kind of features have already been listed for you guys. So this makes it a little easier for the customer to approach the user interface and select the product they're looking for. So this is the kind of features, this is the kind of capabilities which a search engine gives you. Along with that, not to miss, we have the right hand side pane as well on the snapshot, which is basically telling that these are also the kind of products people are looking for. So these are the popular products as well, which kind of match with the search string you're looking for, or maybe the price range you're looking for. So this gives a user a very nice user experience. It gives to the user that they get everything on one comprehensive screen. So they get these suggestions, they get the spell correction, they get the grouping of the products on the basis of price, on the basis of brands, or any internal feature, which is again very, very configurable. Then they also get to know that what type of products are popular in the market, which they might also consider. So this kind of UI is delivered by the search engines. So just to give again a little more depth into it, we have the text-based search, which is provided. If you see here, we have highlighted the field number 1 here, which is there in to ensure that whatever you might be looking for, you can just type in here, and the query is going to be interpreted in the manner which our search engine would understand, and it is going to render all the relevant results to you. Along with that, you have filters therein, and along with that, you have everything pretty neatly organized in form of documents, which are easily sorted as well. So they're all sortable results, which you see here. So Over here, if you look, there are few key features which every search engine, for the matter of fact, should have. So what are they? First of all, they should be optimized for faster text searches. So we have spoken about speed. So speed is the primary and the foremost concern of the web application. And if it is a e-commerce application, then even more important. It should have the flexible schema. So I believe all of us do have some sort of DB knowledge. We all belong to IT, so we do understand that when we talk about schema of any traditional databases, we need to have the fixed schema. So if you're trying to insert insert a data in the database table therein, you need to comply by the syntax and you need to comply by the fields or the columns, we essentially call them. You need to provide the information as per the configuration of that table. If the column does not expect any null values, you need to provide the value for that particular column. So the constraints are pretty rigid. However, a search engine basically should have the flexible schema or no schema at all. So it should also support the sorting of the document. Like I just said, I would want to see the lower price products first, following the higher priced products later on. It should be web scalable, which means that if you have more number of reads coming on your website, more number of say people who are using your website to look for the products, so it should be scalable enough to handle that kind of user flow. Along with that, you need to have the kind of structure that your search engine should be document oriented. Everything pertaining to one single product should be there in one place. So these are few of the key features which a search engine should have. We're not discussing, as of now, we're not discussing Apache Solr. So let's see what all really matches with Apache Solr. Along with that, just to cover up, there is this example which we have taken from another very popular website, ClearTrip, on which basically people would want to see that how far is one place to another, what kind of hotels or what kind of places they can explore when they're planning their trip. They can also see the comprehensive list of the hotels and the star rating they might belong to, the price range in the similar manner, if you would like to check the left-hand side of the website snapshot. Along with that, on the right hand side, the map section which you're seeing in here, we have placed the tags therein that which hotel is placed where. So maybe you would like to explore that. There is maybe a very famous spot on a particular place. So how far is your hotel is going to be from that place, or how far is that particular hotel from the place you're going to be traveling there. Along with that, you would like to see that I'm just interested in the 3-star or the 5-star hotels, so you can select that as well from your left hand side. So this becomes pretty easy for a user to basically shortlist the kind of places or the products they might be looking for. So again, this is another kind of feature which the search application would provide you. So along with that, just to begin with, let me see if we have any questions. Okay, so the hacker has a question here that when you say scalability, do you mean load balancing capabilities embedded? Okay, so the hacker, when I say scalability, I say that imagine I'm serving a e-commerce website application data, and I have, as of now, imagine I have 10 million products as of now. However, in the due course of time, say in the 5 years or 10 years down the line, I'm seeing that my product catalog is going to grow like triple of what it is as of now. So I'm saying that scalable in terms of the storage, scalable in terms of performance. So load balancing is another feature which I would essentially not count in the scalability per se. Did I answer your question, Sudhakar? So as of now, I'm just talking about the data, the amount of data my particular application is going to handle, the traffic, how it is going to handle that. So we're talking about that aspect when I talk about scalability. So when we talk about Apache Solr, I would say the scalability of Apache Solr is unmatched, considering that the kind of giants like LinkedIn, the kind of giants like Twitter and Flipkart and ClearTrip, such people are using it, so you can trust the flexibility, you can trust the robustness which it provides to the application. So along with that, I would also like to tell you that currently it is the most widely used search solution which is present on this planet as of now. So it is established, plus it is growing. It is ever growing, and you have approximately 8 million plus downloads which have been done for this particular application. You have 250,000 plus downloads every month for this particular you know application. Then you have 2,500 plus open Solr jobs if you look for as of now. So every day it is being used by giants, as I've just disclosed: LinkedIn, Twitter, Apple, Netflix, Instagram, and many more such major website and the product providers. So it is catering to almost 100 million requests every day. So imagine the kind of capabilities this might be delivering if it is scalable to that extent. So Kunal has another question here. Other search APIs such as Compass, GP Text, etc. are all based on Lucene. So okay, is this a question for me if you're asking? Okay. So, well, yes, most of them, yes, they are. However, we have custom, if you're talking about the distance APIs, if you're talking about people who are basically leveraging the search capabilities in terms of calculating distance, I think the one you were talking about, the Compass and GP Text, basically they have customized Lucene, considering that it is open source. You don't have to pay anything towards licensing of Lucene. So they can basically go ahead and customize that particular feature of Lucene. As of now, Lucene uses Haversine algorithm to calculate the distance between 2 points, two space points, basically. So however, you have few more variations as well, like you have Elasticsearch. Again, Elasticsearch is also using Lucene at the back end. So by and large, a lot of applications are using Lucene. It's Haversine, Haversine, Haversine algorithm, Kunal. So I have another question here from Kiran. How is Apache Solr different from Solr Cloud? So we would be covering that in a little while, Kiran, if you can hold on to it, maybe for a few more minutes. So let me just go ahead and talk about so Prasad, we have a lot of algorithms which are there in Lucene. Again, covering them in this particular session is little out of scope because we have the designated 1 hour and I have to cover a few more topics. So when you enroll in this course, Apache Solr, along with the Edureka therein, we have 2 dedicated classes. When I say 2 dedicated classes, I say that we have 6 hours dedicated, in which we would be talking about Lucene only. So another question from I think Sudhakar. What is the relation or difference between Solr and Lucene? So again, Sudhakar, the distance is very, very concrete because Solr uses Lucene at the back end. So all the capabilities which are provided by Solr are basically delivered delivered through Lucene. We would be discussing this in the architecture. If you could hold on to this question a little bit, maybe for a few more minutes. Okay. So let me just move ahead. We are going to take logical breaks in between to take care of these sessions because again, we have to stick by the flow as well. So we would not, go out of context for the other guys. So it stays a little easier for everyone to follow. So talking about Lucene briefly, Lucene is the powerful Java Search Library, which again lets you add the search capabilities or the information retrieval capabilities to your existing or newer application. Anyway, guys, any idea about this guy, the pic which we have shown in the insat? Anyone who knows this guy? Doe Cutting. He's the creator of Lucene. Any idea what else he might have done? Okay, Kunal has got it right. Yeah. He's the creator of Hadoop as well. Absolutely. Kunal, Kanan, Arvind, Kiran. Yes, absolutely. Manoj Reddy as well. Absolutely. Fabulous guys. So it seems to me you guys are pretty familiar with Hadoop and the related stuff. Yeah. So we would be discussing how this can, become another feather in your hat, I would say. So Lucene is used by LinkedIn, Twitter, and many more giants. Once this presentation reaches you guys, you can probably refer to this URL and explore this a little bit more. It is pretty scalable and very, very high performing API, which helps you with the indexing and searching capabilities. It provides you with the powerful and accurate and very efficient search algorithms. Again, the algorithm part, as of now, it is a little out of scope considering that we just have an hour to discuss about Apache Solr. So as of now, I would just say that it provides you with a lot of powerful algorithms, like you have phonetic search therein, you have Heversine algorithm to search the distance, you have say Porter stem algorithm to look for the similar words, the synonyms. So these are few to talk about. However, this all is covered in vast details in the course itself. So as I just mentioned, we have 2 dedicated sessions to ramp you up with the capabilities which Lucene delivers. So again, the foremost important reason why it is so sought after is that it provides you with the cross-platform solution. So you can use it on a .NET application. You can use it on your PHP application. You can use it on your Java application. So choice is all yours. You have a lot of variations and you have a lot of variants in which Lucene comes. And again, it is open source, as I just mentioned a few minutes ago. It is open source and 100% pure Java. However, the variants are available in other programming languages as well, which are index compatible. So we would be discussing in a little brief that how this entire thing works. So let me just check if we have any questions as of now. Okay. Kunal has a question. I have customers bugging me on integrating Lucene with their DBs. They use Derby, MySQL, etc. Are there any best practices for Lucene available around? Well, yes, and we would be guiding you through that as well. I mean, if at all you enroll in the course, we have the ways. I mean, people do bring up their questions and people do bring up their use cases along. So we do provide the assistance on how they can embrace capabilities of Lucene and Solr in the existing or the newer application with various technology background they might have. So maybe as of now, I would say that you can probably drop in a ticket to us. Maybe we can discuss about this. So for now, I would just go ahead and discuss about how basically indexing is done and what makes it so powerful. So guys, any idea about, I'm just asking if you do remember how the index in front of your book and back of book varied. Do you remember the front indexes and the back indexes in your textbooks, in your schools? Do you guys remember that? The front index used to talk about the chapter number and the page number it belonged to. However, the back of the book index, yes, appendix, absolutely. So the appendix used to basically talk about all the important terms and the page numbers they occurred in. Yeah, the front one is basically sequential and the back one is basically referred for and is basically used for appendix. So let me just give you a quick maybe flashback. So we had been seeing something like this. Do you guys remember this? So we had something like if you're talking about seal, that apparently was referred on page number 6, 7, and 24. If you're talking about squid, it was referred on 6, 10, and 24. So something like this. So over here, if you talk about Lucene, basically creates similar type of indexes for the process of indexing and searching. So instead of the terms here, these are basically the important terms which are grabbed from the content or the documents which are pushed in to Lucene. So the important terms is basically grabbed in from the documents you're going to pass in. So let me just quickly take a small example here. Considering that we have say, I mean, as of now, we're just taking example of 3 documents here. You could have few million of documents as well. So imagine they're going uh, through the sub process of indexing in Lucene. So imagine these are sample, text which we have spoken about here. We have document 1, which says I like Edureka courses. Document 2 talks about Edureka teaches big data courses. We have document 3 here, which says Edureka helps learn new technologies easily. So you have few content and few text here, which apparently consist of in each document therein. So how Lucene basically converts them into the indexes is similar to the back of the book index. It would gather all the important terms from each of the documents, and then it is going to maintain the document ID, the reference document ID in which this particular document apparently occurred. So if you talk about the process of indexing, it consists of 2 sub processes. So indexing basically has 2 sub processes: the analysis of the text and the storage of this text. So analysis again has 2 sub processes. You have the process of tokenization, and you have another process of token filtering. Now, again, had this been the actual class, I would have actually taken an hour or something to explain these processes, how many different type of tokenization processes, how many different type of tokenizers we have in Lucene, how many different type of filters we have therein. So again, just to give you a little brief about it, to give you an idea how does that really happens, is that the process happens to be like the document goes through the process of indexing, wherein it goes through the process of analysis, and in the due course of analysis, it is basically converted. The text basically is the stream of tokens, and they basically are delimited to form a single token each. These tokens are then delimited on the basis of certain criteria or the rules or the algorithms which are running at the back end. So for an example, if you're using any standard tokenization process in Lucene, it is basically going to take care of all the is, the, and such common words. It is going to take care of removing these words from the text because they do not really add any value to your text or any document per se. So it is going to remove all of that, and it is going to maintain, it is going to just retain the important terms from that document, which again goes through the process of token filtering, wherein you might have something like you might have identified that few type of words I would always like to filter out from my content. They might be called stop words, if you know about little concepts of NLP, natural language processing. So you might want to delimit, or you might want to remove few tokens from your text. So you might mention that in your algorithm altogether. They words along with is and the and common auxiliaries in English, they also would be removed from your text. So the content which remains is the most important content, and that for that content it is going to maintain this kind of reference lookup. Is that clear, guys? Are you following? Are you with me? Okay, Sridhar seems to have another question. Is this Lucene works only with document-based backend? Can it work with RDBMS also? Well, we would be discussing about segregation between RDBMS and what Lucene does. So again, as I just said, RDBMS is basically record-based, and Lucene is basically document-based. So if I have to really, kind of differentiate between them, if you talk about Lucene and RDBMS, uh, you can consider something like a document in Lucene is similar to a record in your RDBMS. So like, could you guys tell me that what is the basic unit of a record? What is there in record? What do you have in records? I mean, if you're looking for a result set which consists of few records, yes, absolutely, columns. Thank you, Kanan. So you have columns therein. In the similar manner, a Lucene document would have fields therein. So like a column would have certain sort of properties therein, like it could be of type integer, it could be of type date, it could be of type varchar here. In the similar manner, in case of Lucene, a document field is going to be of certain type, like string, double, int, could be date as well. So you have a lot of other field types as well here. So you can map or you can relate to this. Did that help, Sridhar? Along with that, so the hacker has another question. So on the comparison, the index would be equivalent to a table and a document is a row. Uh, well, absolutely. Index is actually going to represent a database. Yes, absolutely. So yes, they're also stored in the key value pair. Absolutely. So Lucene works on this environment. Yeah. Okay, I have an application and it has RDBMS. All the product information is there in RDBMS. Example, e-commerce catalog. So Lucene works on, okay, are you asking if Lucene is going to work on this kind of environment? Is that your question is? Yes, absolutely. It is basically designated for a huge number of records. As I've just told you guys, Lucene and Solr are serving 200 million requests every day. And the major reason it is so sought after is that it basically, maintains, it basically helps you storing and indexing huge number of records. So considering if you're talking about e-commerce website or the catalog therein, you would have n number of products therein. So definitely it is the best example. It is the best use case you should be using Lucene. So let me just move ahead. So the process of indexing basically involves, this is again from the code point of view as well. So again, I don't see that we have enough time to get into the code details. So just to give you a brief about what is the process of indexing and how does that really goes about, you have a document, like you have a record in your database. In the similar manner, you would have several fields, like n number of fields would be there in a document, which goes through the process of analysis. In the analyzer, you would have the tokenizer and the token filter, and then this process of and the content, the tokens which are generated from the process of analysis is pushed to the index writer, and each of these tokens are then written on the indexes and then are moved to the directory. So these are the kind of classes and this is the kind of process which is followed by Lucene. In the similar manner, the process of searching goes in the similar manner. You have the text which you enter over here. When we talk about expression, I'm talking about the query or the search string you would be entering on your UI or on your console. So this query as well is basically translated into the expression which Lucene can understand. So this goes through the process of analysis again. So this expression is basically captured in the query parser. In the terms of creating a query parser object, a query is being passed here, and this query is basically analyzed through again the set of analysis tools. So in the similar manner, you have the documents therein which consisted of text and was broken into the some sort of tokens. In the similar manner, your query is also going to be fragmented as well in terms of few tokens. Then the query object is basically formed from those tokens and then they are passed to the index searcher. This index searcher is then going to consult the directory again and it is going to fetch the designated results for this particular expression which you have provided on the console or the UI. Is the process clear, guys? The process of indexing and the process of searching? Do we have any doubts here? Okay, we have a question from Debashish. For Solr using it into a production servers, etc., though it's capable of handling huge chunk of data, doesn't it involve infrastructural cost? Okay, so Debashish, we would be discussing how you can leverage your existing infrastructure if you want to adopt Solr. However, if you talk about any traditional application, you need to have a database, and the database is going to basically work on any commodity hardware. Do you agree with me, Debashish? You need to have a certain limit of a commodity hardware to make sure that your database is large enough to hold huge chunk of data. In the similar manner, you need to have a commodity hardware present and you just need to have the binary present of the Solr. I mean, it's as simple as that you just have to pick the Solr var, and you just have to put into your web app folders of your Tomcat or any favorite, web application server. So again, I cannot go into a lot of details therein because we have limited time frame. So maybe if you were in my one of my classes, we have a complete topic to discuss how this fits into your fit into your architecture. So again, you can probably hold on to a little bit. We would be discussing architecture of Solr as well. So what is Solr? In the similar manner, we have discussed Lucene. Again, I have given you way more than a brief of Solr. So Solr also is the open source enterprise search server and the web application. When I say you could easily pick out the WAR file from the binary distribution of Solr, you could use it as the web application. However, you can also use it as the search server. I mean, if you just want to maybe use Solr from the existing binary. So Solr uses Lucene Search Library, and it extends it for one of the questions which we had from someone, I don't remember. So Solr basically exposes the Lucene's Java API as RESTful services. Do we all understand what is the RESTful services? Do we all understand that? So we have the dedicated web services. Absolutely, Kiran. Absolutely. So we have the web services therein, which are exposed as the RESTful services. So you have the Lucene's capability, which are exposed by Solr as the RESTful web services. So you put a document in Solr, and it goes through the process of indexing. So you can choose any of your favorite format like XML, JSON, CSV, or binary if you want to send it over to the HTTP through HTTP. So you can put in your document, which goes through the process of indexing and is indexed, and then you can happily look for it as well through the process of searching. So you can query it via HTTP GET and receive the response in XML, JSON, CSV. You have other writer types supported as well, in which you can render your results like PHP. You have results which can be rendered in Ruby as well. So you have a lot of flexibility, which Solr provides you. Okay, Kiran is asking me that could you please explain a bit on RESTful API services? So Kiran, imagine you have capability of say querying. I mean, you have Lucene, which exposes the say you talking about querying here. So entire capabilities of querying and entire say the feature set of querying is provided by Lucene therein. However, they're exposed by Solr in the form of RESTful services. So if you talk about RESTful services, you need to have a dedicated you need to have a dedicated custom URL through which you're going to expose the API. So like the querying capability of Lucene is exposed through /query. In the similar manner, you have another querying capability which is delivered by /select. You have custom capabilities which could be delivered by say anything like /xyz, and you can configure it in your configuration files. Maybe you can use your custom servlets here, or you could use simple functions in which you can define your own request handler. So these are basically the request handlers. So we would be discussing this a little more in detail on the architecture. So give me one more minute. So the key features of Solr is, again, for now, I think by now we all have understood that Solr provides you with the advanced full text search capabilities, because the entire processing is done by Solr itself. So you need not to, basically fragment your query as well. You just type your text and it is converted in the format which Lucene would understand. So it takes care of the entire processes therein. The entire capabilities are optimized for the high volume of web traffic. So this was one of the features which we discussed when we said that what all our search engine should have. So it should be optimized for the web volume, high web volume. So Solr provides you with that key feature as well. Again, it follows the standard open interfaces like XML, JSON, and HTTP. So it complies by those as well. And along with that, it provides you with a comprehensive HTML administration interface as well. We're going to take a small demo on that as well, that what kind of HTML administration interface which is provided by Solr. So you can easily take care of posting the document, querying a document, maybe looking at the health of your Solr instance as well through your comprehensive administration interface. However, if you do not want to use that, you can also use JMX as well for monitoring. So again, we have a dedicated session on this as well in your course. You have the capability of near real-time indexing and is adaptable to the XML configuration. So this entire thing, I mean, near real-time indexing and near real-time querying the data, this entire thing is controlled by the XML configuration in Solr. So this provides you with a highly customizable interface and the capabilities. It is again linearly scalable. It gives you the feature of auto index replication. It is you can extend the plugins. You can extend the architecture by adding on to the plugins as well. So the auto index replication and the plugin architecture is basically supported by the Solr cloud instance. So I think we have another question here. Solr is web application GUI available for this application? Absolutely, Kiran. We do have the graphic user interface as well for this application. We would be seeing that in a little while. So how do we index the data? It is through API call or through any tool. Okay, Kiran, you have a lot of flexibility in how you really want to index the data. So you have an API call as well available. If you look here in my architecture here, we have the update handlers, which are similar to the request handlers which render your request. In the similar manner, you have the update handlers. So you can post your data onto the HTTP, or you have the backend capability as well, through which you can index your data through the command prompt as well. Along with that, you have tools like Apache Tika as well, through which you can index the data from various MIME type like PDF, Word, XML files, and say XLS files. So you have a lot of formats which are supported. So what Apache Tika does to Solr is that it is going to give it a very extensible feature that you can use it and you can provide any type of file to Solr. So Apache Tika is basically going to strip out all the unwanted content from that file. It is going to retain the text content only, which is basically the meaningful information in any file. So it is going to retain that, and then it is going to index that information. Is it clear? Is your question answered, Kiran? So we're going to now briefly discuss the architecture of Solr as well. So if you look here, we have been discussing about a lot of things. So maybe this slide might be kind of helping you guys to resolve your doubts. So if you look here, and another thing I would like to add here is that I might extend with say 10-15 minutes. Is it okay with everyone? Because again, I'm handling the questions as well in between. So is it okay if we extend for say 10-15 minutes? Yes, no, maybe? Sure? Okay, Devashi says sure. Okay, I guess, yeah, I guess everyone seems to be okay with it. Thank you so much, guys. Thank you so much. So I promise you are going to have a very nice experience. You're going to know a lot about Apache Solr. So, okay, coming back to the architecture here. So because we do have a lot of questions on where and what all things are there in the architecture. If you notice, we have Apache Lucene here, which consists of the core search, which is index, reader, and the searcher module here. It has the text analysis module here, and it has the indexing and the index writer module here. So all these things, the entire, and I would say the core capabilities are provided by Lucene only. However, Solr, as I just said a few minutes ago, is basically extending the capabilities which are exposed by Lucene. So on top of Lucene, if you see, we have request handlers here. I would start from here. We have request handlers here. So we have slash admin, which takes you to the admin console. You have slash select here, which takes you to the query interface. You have slash spell here, which is again another example of the request handler, which takes care of the spell correction of your text which you're looking for. So you have many more request handlers. Along with that, as I just said few minutes ago, you can also have your own request handlers. You can configure them maybe with the custom servlet, and you can provide the list of parameters it is going to accept, and you can uh, clearly have a customizable interface as well. Along with that, along with request handlers, you have certain search components as well. So query, highlighting, spelling, stats, faceting, debugging, more like this. Okay, there is a typo here. It should be more like this here. And the clustering. These are the search components which are basically going to assist you with the query feature, which you're going to access on your Solr. So highlighting basically provides you with the feature like highlighting the term in a document, which is basically rendered in the search results. Spelling is basically going to take care of the spell correction of the search string, and it is going to match with the spellings which are close by to the search which you with the text you're looking for. The stats is basically going to provide that how a particular document came on the first position and how a particular document came on the second position. So you have all these stats. So this is the search component which is going to take care of all these stats. Faceting, again, as we saw on our screenshot, we had certain grouping done. So the price range, say of 2000 to 3000, was nothing but basically a facet. So there is a little difference between grouping and faceting. Maybe it is again out of the scope of this presentation. So again, you can, as of now, you can take faceting as another variant of grouping. More like this is again the kind of suggestion which Lucene provides you with. Like if you type, say, maybe like maybe you have a document in your index store which says America. However, when you looked for in your search query, you typed something like Enerica. So it is going to basically, first of all, the spell, you can basically have the spell checker module, which can correct the spelling to America, or you could have the capability of adding more like this feature as well, which say that this particular term looks to me like America. So are you looking for something like America here, or are you in particularly looking for Enerica? I'm sure this kind of feature everyone must have seen on Google. Do you guys remember? When you look for something in Google, it would say, do you mean this? So this is the same kind of capability which is provided through more like this search component. Okay, then you have the capabilities of distributed search here. So this distributed search capability is basically taken care of by Solr Cloud. So we would be talking about Solr Cloud as well in a little while. Okay, then we have the request writers here, which is basically going to take care of how your results basically appear on your UI. So do you want to see your results in XML format, or do you want to see your results in the JSON format, or you want to see your results in the binary format? So this entire thing is taken care of by schema and the configuration file. So you have two foremost configuration files, the schema.xml and the Solr config.xml, which play and help you configuring 80% of your Solr instance behavior on your architecture or your application. Then you have the update handlers. So update handlers are going to take care of the beta updates you're going to delta updates which you're going to make onto your server. So like you're going to add more data on your search server, so they are going to be taken care of by update handlers. So you can provide the data in the XML format or CSV format, JSON format, or the binary format. So they're going to take care of the updates which you're going to make on your search server. Update processes are basically going to take care of the processes like signature, like you want to ensure that the security is another feature you want to take care of. So you can configure like you're capturing the payment information and you would like to match the signature of the information. So you can have those kind of features as well. You can have logging and indexing processes as well, which would be again assisted along with the update handlers. Along with that, it provides you with the query parsing, the analysis feature. These features like faceting, filtering, search caching, and highlighting are similar to the ones we have in the search components. So these are the ones we have added these again here, because these are the ones which are going to take care of the content which is returned by Lucene, because the results are basically returned by Lucene only. So on these results, you can have the features like faceting, you can have the features of filtering, you can have the features of searching, caching, and highlighting on these search results. Along with that, we have Apache Tika here, which is basically going to take care of the extracting of the content from various MIME type files, like PDF, Word is one of the examples we have taken here. You can also ensure the information extracted from JPEG files as well. You can extract the information from XLS files as well. Then you have a very nice feature here, which is called data import handler, which is basically going to take care of the importing the data from the existing data sources or the RSS feed therein. And you have another nice feature of index replication, which I said is supported by Solr Cloud. So any doubts till here, guys? Okay, so Kunal says, I see index replication. Would the index size be limited to the storage memory available on the infra? Absolutely, Kunal. I mean, the index replication definitely would be dependent on your infra plus the replication factor which you're going to define. So again, you need to choose the replication factor wisely per the infrastructure which is available to you. Or there is some way that Solr can distribute indexes on multiple boxes the way other distributed technologies such as Cassandra does. So yes, definitely you can use the capabilities of that as well. We're going to explore the possibility of using such kind of things as well along with Solr. So maybe, so I guess we're clear about the search process. So maybe you can talk about a user, and user basically accesses the search features through any of the request handler. The request basically goes through the query parsing process, which is basically going to convert the query into something which Solr can understand, which is then going to consult the indexes which are stored on your commodity hardware. And then you can have the pagination features as well. So over here, we are talking about QF here, in which you can possibly have a feature like select maybe first name, last name, and department from employee table. So query field is basically going to take care of how many fields are basically wanted in your search results. So what all fields are you basically looking for in QF? So these are the query fields. The def type is basically going to take care of how your query is going to be parsed. So again, we have the dedicated classes on this in our course. The start and rows, number of rows, is going to be taking care of the pagination features on your website. The FQ is again another feature which works on your complete result set. Like you would want to have additional, say, filtering of data. So the FQ is basically filter query, which is going to be operational on the complete result set, which is rendered by the indexes. And then you have the response writer herein, wherein you can define WT equals to maybe XML or JSON, and you can basically return the results in the format you would like to see them on the UI. So near real-time search, as we spoke about, so this means that the documents are available for searching almost immediately after being indexed. So as soon as you push the document inside the indexes, they're going to be available for the searching as well. So maybe if you push the document, say on an instance, and immediately you query something in which the criteria matches with the document you've just indexed, the document basically is going to be rendered to you. So this is basically controlled by again the configuration, the auto soft commit property therein. So you have soft commits and you have hard commits. So soft commit is basically going to talk about the visibility of the documents, and the hard commit is basically going to take care of the durability of your documents or your data. Then similarly, you have the real-time get, which basically lets you query and get the document of your choice by a unique ID, which is assigned to each of the document. So if you know the document ID of any document, which is basically generated on the runtime, and it is done by, you can do it manually as well. And if you're not providing any document ID per se, so Lucene is going to assign one document ID to it. However, if you know the document ID, you can basically get that particular document through the document ID, the latest version of that particular document. So this is primarily very, very useful when you're using Solr as a NoSQL data store and not just a search indexer. So if you look here, we have real-time get here. So maybe we can take an example on this. So I'll just move ahead. We can probably take an example on this. Okay, I think we have few questions here. Let me just take a couple of them. Faceting is similar to filtering search, like brand filtering in Flipkart. Absolutely. So you can say that faceting is nothing but a type of grouping. So probably you would like to have your results grouped in on the basis of certain criterias. So brand could be one of the criterias. So yes, it means the same thing. So Sridhar seems to have another question. Do we use Lucene or Solr together, or Lucene could be used with any other like Solr? Well, Lucene is used by Elasticsearch as well, just to let you know. However, if you're using Solr, definitely you're bound to be using Lucene, because at the back end it is using Lucene. However, you can use Lucene independently as well, which is going to be very, very tricky. So again, it is kind of recommended to use Solr. Are joins recommended in this architecture? Not really, Sudhakar. I mean, in the similar manner, I mean, I'm sure you guys are pretty, pretty familiar with Hadoop. So I'm sure you know that a denormalized type of structure is basically recommended for Hadoop. In the similar manner, Solr also recommends a flat type of structure. So however, you can definitely draw the joins. I mean, if you want to see and if you want to have relationships defined, definitely you have a way around. So again, we have a designated session on this as well in the course. So, okay. So we have another question here. My e-commerce platform will be in PHP and MySQL. So how can I use Lucene in my application, and what is equivalent to Solr for PHP application? Well, as I just said, Sridhar, I guess. Your name is written as Setu. So I'm not very sure how do I basically address you. So let me just address you with Setu only. So as I just said, you can have your results returned in the designated format. So maybe when we take the lab exercise, when we take a small demo therein, this might be more clear that what all formats are supported. So Solr is something which can help you when rendering the results in PHP format as well. So we would be seeing that in the demo part. Is it fine, Setu? If you still have any doubts, maybe we can clear that up after the demo. Okay? Yes, no, maybe? Okay, sure, absolutely. So then we have the Solr cloud. So I guess this has kind of been waited for quite some time. People have been talking about Solr cloud. So what exactly is Solr cloud? So Solr cloud is, it gives you the ability to set up a cluster of Solr servers. So it is basically, you can imagine the Solr capabilities in the clustered environment. It combines the features like fault tolerance and high availability of your instance. So imagine you want to have the capabilities of Solr in your application, and you're working in the clustered environment. So Solr cloud is something which is way more recommended for you, because that ways you can ensure that if any of your node gets down, you have the automatic failover, and your instance is going to be highly available. I think these are two foremost things anyone would look into when they're working in the clustered environment. So both of these concerns are addressed in the Solr cloud environment. Then we have Solr cloud, which is very flexible in distributed search and indexing. So it works without master node to allocate nodes and shards and replicas. So maybe if you guys are not very familiar about the terms which we might be using here, just to ensure that everyone is there on the same page. So we have the traditional master and the slave architecture. So Solr cloud does not really works on that kind of architecture. We have first of all, we have the zookeeper instance. I'm not sure if every one of us are aware of what zookeeper is. Are we all aware of what zookeeper is? So in brief, I would say that it provides you with the centralized configuration or the cluster state management. So it is going to take care of the leader election basically. And as of now, if you're wondering what leader is, so leader is again another type of node in your cluster which takes care of your write requests. Then you have replicas, which are the copy of the shards in a collection. So maybe you might be wondering what exactly shard is. So shard is a logical slice of a collection. So we have been talking about few terms here. Okay, we have few questions as of now here. So let me just quickly cover this slide and then I can come back to the questions. So we are introducing few concepts here, guys. If you can pay a little attention. We have introduced zookeeper here. So are you guys aware of what zookeeper is? I'm asking again. So zookeeper is something which is going to take care of your, okay, not sure. Okay. So it is going to basically take care of cluster state management. And say it's the centralized, I would say centralized system, which is going to take care of your cluster health as well. Then we have leaders here. Before going on to the leader, let me just explain the basic part. Then we have the collections here. So what exactly is the collection? We've been talking about the indexes here. So these indexes are basically distributed. These basically they're basically distributed on multiple nodes. So the indexes with the say same configuration are called collection. Is it clear? Are you guys following what collection is? So collection is nothing but you can in the very layman term you can call it as indexes. So collection is nothing but index. Then you have shards. So shard is say a logical slice of this index. Logical slice of collection. Then you have a leader here. Leader is basically a node in charge for writing the data, basically involves in indexing. Then you have replicas here. So replicas are basically say replicas of shards here. So they are basically responsible for search, rendering the search features on your application. And then you have nodes here. So I mean, we have been talking about leader and replica. So these are basically the nodes. So node is nothing but a JVM process, which is bound to a particular port number. Is it clear, guys? Okay, collection is confusing, Setu says. So collection is nothing but indexes which are generated by Solr. Is it clear now? So indexes which are generated by Solr is called collection, is called indexes. So when you talk about a collection, These are basically the indexes which are designated for a particular node, particular instance, I would say. And then you have the overseer. So these all these terms are basically pertinent to the Solr cloud environment. So overseer is basically a special node, I would say, which basically takes care of the cluster administration. So it is going to take care of your zookeeper. So it is going to basically take care of this. So maybe when we are going to discuss the Solr cloud architecture, maybe this is going to be more clear then. Shall we move ahead? So we have the architecture here. Maybe this is going to be more clear now. Okay, so the hacker is asking, where does the directory fit in this explanation? Okay, directory, you're talking about the file system directory, Sudhakar? So I'm not sure what your question is. Okay, let me just go back to the previous slide. Okay, the directory analyzer. Okay, okay, that directory you're talking about. Okay, the directory which I'm talking about, directory was basically the class, Sudhakar. I mean, you can have the file system directory, you can have the RAM directory as well. That totally depends on where are you planning to store your data or your indexes. So that is what I mean. Directory you can talk about is a class from Java point of view. So directory is any place where you're going to store the indexes. So you have various type of directories therein. So you can have a file system directory, you can have the network file system directory, you can have the uh, say RAM file directory as well. So overseer, I'm Kiran says, please explain again. So Kiran, if you look here, this is I mean, maybe that is why I'm saying it would be more clear if we look into the architecture here. So imagine you have millions of documents here. If this the terms which I've introduced are not yet clear, you can let me know. I mean, I'm just trying to map the terms which I have introduced on this particular architecture. So maybe you guys would be able to follow this now. So imagine you have millions of documents which are coming in, and you have millions of users which are basically playing around with these documents. So in the Solr cloud environment, you're going to be accessing the APIs which are exposed, the RESTful web services which are exposed through XML, JSON, or HTTP. So the millions of documents also go through the process of indexing through this RESTful web APIs, and the users who are querying or using these documents also use the similar web services. Now these web services basically talk about this. I mean, I'm talking about when I'm talking about the REST web services, I'm talking about any say Solr cloud instance. So this has exposed few web services here, and this is basically going to take care of this is basically going to take the request which comes on this particular say web service, and it is going to consult the load balancer as to which service, which web server, or which node basically I'm supposed to be sending this request to. So you have, as of now, you have two servers here, server 1 and server 2, which have instances running on two port numbers. If you look here, 8984 and 8985. So you have leader and you have the replicas here. The process of replication creates a replica here for this particular collection. Is it making sense, guys? And in the similar manner for collection 2, you have the leader here and the replica here, which also goes through the process of replication. So the replication factor of this particular instance is 1. Okay, is load balancer part of Zookeeper? Vivek asks me. So load balancer is not the part of Zookeeper, Vivek. So I'm talking about any traditional web application as of now here. It is not part of the Zookeeper. It is part of basically the Solr cloud. So who is basically supposed to get the request is basically taken care of by the Solr cloud. Because imagine we have the centralized configuration management system here. So this is basically the overseer. I believe somebody had the question. Kiran had the question that what is overseer. So overseer is basically going to take care of the centralized configuration management, which is going to have more than one instance of zookeeper as well, just to ensure that zookeeper should also not fail. Okay, Setu says, what are prerequisites of this course? We are going to discuss that, Setu. Please give me a few minutes. We would be discussing that as well. So, are you following, Setu? Are you in sync with what we are discussing as of now, the architecture? So this is the overseer, Kiran. We have the centralized configuration management here, which is going to hold multiple instances of zookeeper just to ensure that zookeeper should also not fail. So zookeeper is basically going to take care of the leader election, and it is going to basically choose that which port or which particular shard is going to be chosen as leader. So it is going to basically monitor the health of each node. Is it clear? Is it making sense? Do you still have any confusions on the architecture? Any confusions? Okay, Setu says a lot of confusions. Okay, all right. So Kiran has another question. Millions of document match with centralized configuration management. I'm not really sure what you mean. Okay. I'm really not sure. Kiran, could you please paraphrase your question once again? Okay, millions of documents and centralized configuration management you're saying are same. Is that your question is? No, not really. Millions of document is the one which are supposed to go inside for indexing your data, your raw data, which is supposed to be indexed. Those documents I'm talking about. And centralized configuration management is internal part of your architecture. Is it clear now? Are you clear about the segregation now? So this million documents is external to your environment. They're not part of your environment until they go through the process of indexing and come and sit in your collection. Another question from Sudhakar is did not understand why shard is a leader. Okay, well, not really shard. I mean, we're talking about a node. If you look here, we have node 1 on port. If you look here, this is what I meant. Shard is basically not the leader. So this is just for the correction here. Is it fine? Any confusions now? I mean, I'm talking about leader node here, leader node and the replica node here. And basically, it is going to consist of any, a logical slice of the data of the collection. So that is why we have mentioned that information here. So let's not get into a lot of details as of now. Maybe if you join the course, we have the designated 3 hours to study this architecture only. So let me just move ahead. I'm sure a lot of us know about Hadoop. If you still have any confusions here, maybe you can send in a mail. We can clear more doubts through your mail. So considering we would have, Setu, it's not my email ID. Apparently, that is not part of the agreement. I'm not supposed to be sharing my email ID. You can drop in your questions on Apache Solr at Edureka. So I guess a lot of us are pretty aware of Hadoop here. So how can we leverage the capabilities which are delivered by Hadoop when we are using Solr? So what we're trying to do here is we are trying to basically leverage the capabilities of Solr on a system which is basically using Hadoop here. So we know that search, is the foremost, expertise of Solr. So Solr provides fast and efficient and powerful text searches, and that too in very less time. And Solr Cloud is flexible enough for supporting the distributed search and indexing. So it is going to take care of all the things like automatic failover, etc. So when these things are basically set up in the clustered environment, you might want to have this cluster to have Hadoop as well. So it can act as a very nice substitute for the NoSQL as well. So instead of using any traditional databases, you might want to use Solr or Hadoop therein. So what you can do over there is that you can leverage the searching capabilities of Solr, and instead of storing your indexes in the file system, you can store them on Hadoop. And you can basically run the MapReduce job on your indexed data therein, just to achieve the optimized storage of your indexes. So this type of architecture basically is used in Cloudera, Hortonworks, and MapR. So where you can integrate Solr and Hadoop easily. So let us quickly take a look at the architecture as well. So if you talk about, what I'm saying is that you have the input data, which may come in any format like PDF, Word, HTML, XML, JSON. And imagine that goes through the process of indexing. So on this arrow, imagine you have the process of indexing going on. So these indexes are then dumped into HDFS. So on one part, you would have the raw files, and on these raw files of the indexes, you would run the MapReduce index jobs. So basically, they're going to be stored into the more organized and more optimized manner. And they basically converted into the more, say, I would say, just to ensure that you can store more number of indexes on one single HDFS, the file system. So similarly, whenever you're going to have a feature of, say, searching in your web application, you can interact through your Solr instance, and instead of consulting through your file system directory, your Solr is basically going to query the HDFS, and Solr is basically going to query through Lucene. So your query and responses are basically going to be taken care of by Solr, and the the indexes are basically stored into HDFS. Is it making sense, guys? Okay, Anirudh says, could you explain the slide once more? Sure. So let me start with this again. You have the index data. You have raw data, I would say. You have a raw data, which can come in any format, as we have discussed. It supports a lot many type of data formats. So on blue arrow, imagine you have the process of indexing, wherein the tokens are generated. These tokens are then pushed to the file system, where the indexes are supposed to be stored. So these indexes, instead of storing on file system, we are saying that we are going to store them on HDFS. So these raw files would be stored by Solr, and you would have the MapReduce job here, which is basically going to take care of the optimized storage of these indexes. And then when you query, you basically query through your user interface here, and this entire thing, this entire interaction has been taken care of by Solr, which in turn is taken care of by Lucene. So instead of consulting the file system for indexes, you would be consulting HDFS. Is it now clear, Anirudh? Do you still have any confusions? Yeah, anytime. So HDFS store only index data. It will maintain the raw data and index data. That's what Kiran's question is. Absolutely. So it is not going to basically store the raw data, raw index files. Maybe the slide might need a little correction here. So we are storing the raw index files. I'm going to show that how raw index files look like. So let me just quickly show that to you guys. So if you look here, these are the collections which I'm talking about. So these are basically the cores, CORES, cores. So like I've maintained a core here. So every core needs to have a configuration, and every core needs to have the data. In this data directory, we have the indexes. So I'm saying, instead of storing these indexes on the file system, I'm trying to push these index files onto the HDFS. And then HDFS takes care of optimizing the storage of these files. Is it now making sense, guys? Okay, great. So this is how my normal instance would look like. So let me just take a quick demo as well at this point in time. So if you have to start a simple instance of Solr, you would simply say bin Solr start. So this would by default start on 8983 port. So if you look here, we have the process here, which starts, and it is going to load all the cores you have available here. So I have 1, 2, 3, 4, 5. I have 5 cores available on this particular Solr instance, one single Solr instance. So I'm supporting 5 cores here. So 5 cores as in I'm supporting 5 different type of collections here. And these collections, if they're working on any distributed environment, they can sit on different nodes, different shards basically. So this is what I basically meant. So these index files are basically distributed over different shards. So a logical range would be defined, like from this particular hash code to this particular hash code, they're going to be there in one shard. So this is basically more relevant on the distributed environment. As of now, I'm just running Solr in the normal mode. So let's look at how this looks like. So if you look here, this is my Solr console, and this is how my cores would look like. So all my cores would come here. Imagine I have a lot of data on this particular core here. So I have 59 documents here, and you can look at all the stats for each of these. So you can query the documents as well. And if you look here, you can push in the documents in all of these formats. You can basically upload the file as well here. All of these would be sent to the /update. Again, another request handler. So let me just try pushing one document, demo session, say 18 June. And I need to have this particular field in my schema. You have a lot of other capabilities like dynamic fields in which you need not to define any field. You can run Solr in the schema-less mode as well, where you need not define any sort of field. It is going to construct the schema on fly. So imagine I have something like this, and text is say anything like um, demo of Solr document pushed for indexing. So I'm simply going to submit the document. It goes inside. So let me just see if I want to look for something like this. I simply go to the query console. So this is like star.star on your normal database. However, it also supports the fielded searching as well. So likewise, I want to look for demo session 18 June is kind of ID I'm looking for. So it is simply going to render this document to me. So did you just see? I mean, I've just pushed the document and it is readily available for me in the search results. So this is how fast it is actually. Is it clear, guys? Any confusions? Yes, we are simply going to go ahead and cover the yarn as well. Any guys, any idea about guys what yarn is? Yet another resource negotiator. So this is introduced with Hadoop True. And as we know that Solr basically takes care of the ad hoc querying capabilities, Yarn is basically going to take care of the separating the layer wherein you're going to organize and assign resources to a particular job and scheduling of job. So basically it is segregating the resource management and the job scheduling in a Hadoop cluster. So you can very well use Yarn in Solr as well, or other ways. I mean, using Solr in your cluster, which is managed through Yarn. So if you look here, I think I have few questions. A collection is equal to the entire product catalog in the application. Well, that's kind of the segregation you can have, Setu. If you're talking about product catalog, maybe I can store maybe the electronics data on one collection. I can store the apparel data on one collection. I can have the furnishing data on another collection. So this kind of segregation is decided by the business or the stakeholders, or I mean the product owner, I would say. Yes, Kunal, I'm going to cover Yarn right away. So we're going to get optimized storage using HDFS, or we get speed also, Vivek is asking me in terms of response. So again, Vivek, in terms of storage, I'm saying the storage is basically optimized for usage in HDFS. However, the speed is anyway taken care of by Solr. Is it clear? So your catalog is in RDBMS, which is fine. You can happily export this catalog from RDBMS as well through you by using data import handler. So let me just go ahead and cover this slide as well quickly. I'm not going to go in a lot of details. So as I've just explained that Yarn is going to take care of the resource management, and the job scheduling has been taken care of separately. So imagine if you have a Yarn cluster here, and you have HDFS, which is here. So imagine your indexes are going to sit on your HDFS, and you have the Java application, which is going to basically trigger the master application. So essentially, if you look here, you need to have a Yarn node manager on each of the nodes in the cluster, and in each of the Yarn container, you would have separate processes. So like I have Solr master app in this particular node, and I have Solr say replica, or Solr say slave application here. I'm taking example of say sentiment analysis application. So I'm also taking example of Spark here. So the basic job of Spark and Storm is to basically gather the data. So we're just talking about gathering the data. So I need to have a parallel process which gathers the data, and I can have another process which is taking care of indexing the data. Say another process in Solr which is taking care of indexing the data, and another one which basically schedules the map reduce processes. So if you comprehensively look here, I have number one job is basically to fetch the data. So this could be from your feeds, this could be from your FB context, or rather status you call them as. The other one is basically going to be the Solr indexing process or Solr indexing job. The third one is basically going to take care of the say I have HDFS map reduce job, or say pick job. And the fourth one is basically taking care of your search capabilities, again delivered through your Solr. So imagine what Yarn does to this kind of cluster is that it is basically going to manage that the resources are correctly organized and managed. So Yarn is very simple in terms of the few commands which you need to run. So the main benefit of running this kind of distributed application, like we're talking about Solr running in distributed mode, in Solr cloud mode. So the major advantage is that you can improve the operational efficiency. So you're separately handling or separately taking care of your data which is getting fetched. Your indexing is again getting taken care of. You have the map reduce job as well. So the resources are basically managed, and the job scheduling is not supposed to be done manually. This has been taken care of by Yarn, and this entire thing has been taken care of. I mean, because we're talking about Solr running in cloud mode, we need to have the Zookeeper instance, which is going to take care of Solr being highly available, which is basically going to take care of all your abilities of Solr cloud, like the replication factor and the automatic failover. Is it clear, guys? So basically what we are trying to achieve here is that we are basically trying to achieve additional computing capacity to an existing cluster by using yarn here. So Solr could be one of the sub processes. So imagine we are trying to use Solr as one of the processes, and we are going to basically use Solr as in the distributed mode. So imagine you are leveraging the capabilities of a Solr cloud for providing the distributed search, and that too is taken care of basically in the clustered environment. Is it clear? I'm not going to go in a lot of details here because I see that people are getting kind of confused. Setu is asking me, is Hadoop mandatory to join in this course? No, not really, Setu. I mean, this is just an example. I mean, if you know Hadoop, maybe this is again another add-on. Okay, Setu says you're already giving a lot of details, so no more details as of now. I'm not giving any more details. So Anirudh says, example to explain yarn, please. Well, I'm not sure if sentiment analysis example really helped you, Anirudh. Okay, great. So, all right. Again, the foremost and the most important thing for you guys. So the job trend, if you look into, is ever growing in Apache Solr. So how does Edureka works? I'm not sure if all of you know how Edureka works. So we have the uh, classroom sessions. We have 3 hours on Saturdays and Sundays. So these classes are basically the live classes. And if you enroll in this course, I would be taking you through that. So the class recordings are basically available in the LMS, which stands for Learning Management System. So they're basically uploaded for the lifetime access. So you can anytime go back and check into the recordings. And we have 24/7 post-class support, which is provided by amazing, engineers we have in here. Then talking about the material, the study material we have. So we have very comprehensive study material, which is provided when you join the course. So you can access the sample slides. So this is the kind of content we deliver. Then we have module-wise quizzes as well, just to ensure that the learning is going on the right pace. And along with that, we have the project work, like any other course might have. So you need to complete a project work as well. And then you get the certificate as well, which you can share on your LinkedIn. And it's pretty much verifiable. You can use it and you can look for the job as well on behalf of it. So just to give you a brief insight of what we cover in this course, we cover, as we said, that we are going to dedicatedly going to study Lucene in the first 2 sessions. So the first session is going to talk about introduction to Apache Lucene and exploring Lucene. And then you have introduction to Apache Solr and how indexing works, how searching works in Solr. Then we are going to discuss about the extended features as well, like what all you can really achieve. Then you have Solr Cloud and Administration, which is a separate module altogether. And then you have the final project module. So these are the modules in this particular course. And if at all you're taking admission into this course, yes, it is the online course, Setu. It is going to be delivered in the same medium as we are having this session. So if you go ahead and enroll right now after the session, I mean, not a limited time offer as such, but then there is an exclusive 25% discount on the attendees of this particular session on Apache Solr course. So to avail this, you can probably reach out to these numbers. So, okay, let me just quickly go to the questions. Okay, so what are the prerequisites to understand the course? Well, you need to know a little bit of Java and databases. That's about it. And obviously, if you are using computer and you are working in as engineer somewhere, I mean, you would just be ramped up as soon as you join in. So the duration is of 1 month, 8 weeks, basically. 8 classes. So 4 weeks. You have classes on Saturdays and Sundays. Saturday 3 hours, Sunday 3 hours for 4 weeks. So 8 classes total, 24 hours is what the duration of this course. Well, you can look for the price on the website, Setu. I have another question from Anirudh. Does Zookeeper keep an eye on the health and all nodes? And if one of the nodes is underperforming, it changes the leader selection. Absolutely, Anirudh, which is correct. Your understanding is absolutely correct. So Setu, we do not conduct daily classes. This is basically designated for the working professionals. So this is basically arranged on the weekends. You have classes on weekends, basically. So are we all good, guys? If you still have any questions, feel free to drop in your questions on solar@edureka.co. What time in the weekend? Okay, Vivek is asking me. So you have two slots. You have morning slot and you have evening slot. So you can get more details on contacting the numbers which we mentioned on the slides. All right. So I believe we had the nice fruitful session. Do provide your feedback, guys. It helps us improving the curriculum and ourselves. It was great interacting with you guys. Looking forward to have you all in the sessions and in my class. Thank you so much. Have a good night. Have a good day. Thank you. Bye-bye.